So welcome to the video key for the test, the geometry trig test. So the first question was one that a lot of people either skipped, didn't attempt, or did like one part and then stopped. So definitely want to spend a little bit of time on this question. So the first thing that's given is that the area of triangle ABC is 53.4. So that's the area of this triangle right here, okay? So we know that the formula for area of a triangle is equal to 1/2 AB sine C, okay? That's given in the formula booklet, so just look it up. So they tell us that the area is 53.4, so I'm going to plug in 53.4 there is equal to 1/2 AB. So now look, this is a radius, right? So it's R and R. So this is a central angle. And so our A is R and our B is R. Okay. And then the sine of C, specifically our angle right here, is 72 degrees. So I'm just going to plug that in. Okay. So if I wanted to simplify this, I have 53.4 is equal to 1/2 R times R is R squared sine of 72. Okay. This becomes now a calculator question, so I can go right here to y1 and I can put my 53.4. I can go to my y2 and I can put in this right here, which is 1/2, so 0.5. R squared, I'm going to use x squared, and then sine of 72. Before I hit anything else, I want to make sure that my mode is in degrees. So I'm glad that I caught that. Otherwise, it would give me a wrong answer. So mode is going to be in degrees. And I'm going to go back to this. So now I'm going to go ahead and hit graph. Ignore those little plots. So now 53.4 is way up here. Okay. It's all the way up there on the top. And I see that my 1/2 R squared sine 72 is going to look something like that. So let's just, yep. So now I want to see where these two meet. Let me just go here to my plot, turn that off. Okay, so now I should be able to actually see the quadratic. All right, whenever it feels like graphing. So now what I want to do now is I want to see the point of intersection to find out what my R is. So I know that my R is not going to be negative. So I'm going to go ahead and hit window. And I want to change my Y max since I know that my highest point right here is 53.4. Let me just go 60 and let's see if I see it better. Okay, good. There's my Y1, the 53.4, and there's my Y2. Okay, so it looks like, just for symmetry purposes, it looks like it's going to cross somewhere over here. Okay, so I need to move my graph over a little bit more to the right. So I'm going to change my X max. So go to window. I'm going to go to my X max right here. And let's just say I change it to 20. Okay, so now I should be able to see it. All right, so why am I doing all of this, right? I'm doing this because I want to see where they intersect. And again, my R is going to be positive, so I'm not even going to look at the left side. I'm just looking at this right here. So I'm going to hit second trace or second calc, option number 5, which is intersection. You can move over to it if you'd like. Enter, enter, enter should do the deal. There we go. So 10.596989, okay? So that's our value of X. And if I go over here, let me just see, right? So my X is going to be there. All right. So that's my value of my radius. So R is about 10 point, what do we say, 9 something, right? 10.596. So 10.596, and then you write down the rest of those numbers. So that is our radius, okay? So now that we have our radius and we have the area of our triangle, I can see that the sector plus the triangle, sorry, this little section that I'm looking for, the shaded area, plus the triangle is going to give me the area of this sector. So the second thing I want to do is look for the formula for area of a sector. So area of a sector is 1/2. Let me just see if I can pull up my formula booklet. I figured it out. Yeah, so 1/2 theta r squared. Okay, so 1/2 theta r squared. So 1/2 theta r squared. And so to figure out how much this shaded portion is, I'm going to find the area of the sector, and I'm going to take that number and subtract the area of the triangle from it, which is 53.4, and that's going to give me the area of the shaded region. So now I have to just go ahead and do this, right? So 1/2 theta. All right, so now this is the thing that the reference sheet or the formula booklet does not tell you. Um, this, let me just change this color. This theta, this angle, has to be in radians, right? So you have to convert this 72 degrees right here. You have to convert 72 degrees to radians. So how do you do that? How do you convert from degrees to radians, right? All you do is you multiply it by pi over 360 degrees, okay? So let me just go ahead and take our calculator and just do that real quick. So 72 times pi, so I'm going to rewrite this as alpha y equals, right? Put a fraction in, so there's going to be pi on the top, um, and then divided by 360 degrees, right? 360. So now this is going to give me a decimal value, um, but that's going to be what pi is equal to. Okay, so it's going to be something like this. So let's just say you're like, this looks messy. You could also go ahead and do this 72, right? This is 72 times pi is equal to 72 pi over 360 degrees. So if I take my calculator and just rewrite alpha y equals option number 1, if I just reduce 72 over 360 and leave the pi out of it, that is the same thing as 1 over 5. So this is going to be the same thing as pi over 5. So I made a boo-boo and nobody told me. Look at this. What kind of video watchers are you? So to convert from degrees to radians is pi over 180. Okay, pi over 180. So I'm going to do 72 pi over 180. And that should be, let's go. So 72, let me just, I'm a little lazy. So instead of the 360 right here, I'm going to go ahead and type in 180. 180, hit enter, and I get 2 over 5. So this is the same thing as 2 pi over 5, okay? So now let's go back over here, and I'm going to plug it in right here. So it's 1/2 times our pi is 2 pi over 5. Our theta is 2 pi over 5. And then our radius squared is going to be this number. So it's going to be times 10.596, all of this squared. And then you're going to subtract 53.4. Watch how I do this on the calculator, because remember, you're not going to go ahead and take that value for x that we got. You are not going to round it, okay? So this is not going to be like, oh, it's about 10.6. No, we're going to go ahead and take this whole thing and type it in exactly as it is. So alpha y equals option number 1. I'm going to type my 1/2. Then I'm going to go over here, and it's times, and I'm plugging in 2 pi over 5. So alpha y equals, again, option number 1, 2 pi over 5. And again, you should be doing this yourself. Do not just wait for me to do it. And now I'm going to take my radius squared, which is x. That's stored for x. So I'm going to do x squared. And then I'm going to do minus 53.4. 53.4. Okay. Hit enter. And this is my answer, right? So I'm going to round this number to 3 significant figures. So that is 17.2. So the area, so the answer to the question, the area of the shaded region is going to be about 17.2. And in terms of units, it's going to be centimeters to the second power. So 17.2 centimeters to the second power is going to be our answer. All right, so for our next one, okay, this is worth 9 points. So the first thing that I see is we want to find x. So this right here. So I'm going to look at this triangle right here. I can see that I have a side. I have this side. I am looking for this side. but I have the angle that is opposite it. So three sides and one angle, something is missing. That is the law of cosines. The law of cosines, LOC. Lock it up. Okay. So for part A, let's go ahead and use law of cosines. So I'm going to have x squared is equal to the law of cosines. If you forgot what that is, go ahead and look at the formula booklet. But x squared is equal to the two other sides squared. So it's going to be 95 squared plus 112 squared minus 2 times 95 times 112. And it's going to be cosine of the angle that's in between these two, which is 76, cosine 76. So take this whole thing, plug it into the calculator, and then find the square root of it, and you get that x is going to be about 100, and three significant figures is going to be 128. Okay, and again, do this yourself. Do not just take my word for it. Okay. The next part B. So for part B, I have to now find theta right here. So I already know that this right here is 120, about 128. So let's come up with a plan of action. Okay, so I have this side now. All right, looks like I have this side and this angle. And I am looking for theta. All right, so if I try to use law of cosines here, I can't because I don't know what this side is. Okay, but I do know x now. So let's see if I can use law of sines. Find out, here's my plan of action. I'm going to go ahead and use law of sines to find out what this angle is. And then once I find that angle, I can subtract because a whole triangle, right? All the angles in a triangle add up to 180. So once I figure out what this is, plus 19, that's and I subtract it from 180, that's going to give me what theta is right there. Okay. So to do that, I know law of sines. Okay, let's do this in black. So law of sines is A over sine of A is equal to B over sine of B. So I figured out right now this is 78 over sine of 19. So let me apply it. 78 over the sine of 19 is equal to B, right, which we found out was about 128. Remember, you're not going to use the rounded number. You're going to use the number that's in the calculator right here. So 128 point whatever, 14 da da da, sine of the angle. So we're looking for this angle right here. Let's call this angle B. No, well, technically this is angle A, right? So let's call this angle A. All right. So you cross multiply here. So to do law of cosines, I'm going to do the 128, which is my answer. So I'm going to go up here and grab it, and I'm going to multiply it by the sine of 19. So sine of 19. I'm going to close those parentheses and then hit enter, right? And so now I have sine of A times 28 is equal to that answer. So I'm going to take this divided by 28, hit enter, and that's what, so I just figured out what I did wrong, right? So this is 78, not 28, okay? So that is important. So I'm going to take my answer from here and I'm going to divide it by 78. Good. And so that's going to be what the sine of A is equal to. So sine of A is equal to whatever, 0.534. So now I'm looking for angle A. So to figure out what that is, I'm going to hit second sine or inverse sine of this answer right here. And I'm going to hit enter. And that's going to give me about 32.333, whatever. And so then I'm going to do, right, that's going to give me this angle right here. So this I just found out was about 32.3. And then I have to do 180 minus that answer. So part C is 180 minus 32.3 something, and that's going to give me, so let's just do it, 180 minus the answer that we got from here, And remember, we're not rounding until the end. So this answer is going to be about 147. And I still have to subtract this 19 from it, right? So 32.3 plus 19 plus this theta, all of that together equals 180. So I have to do minus 19, hit enter, and I get that my theta, which is what I'm looking for originally, is equal to, let me just put minus 19 as well. So my theta is equal to about 129 degrees. Okay, this is theta. So technically that was still part of B. Okay, so theta is equal to about 129. So I have that answer. I found my X. And now I can find the total area of the lawn. So for part C, the total area of the lawn. Again, for area of a triangle, it's 1/2 AB sine C. So let's do that. So 1/2 AB. So if I use this triangle, the purple one that I was doing before, so our A and our B are going to be 95 and 112. So let me come back down. 95 times 112. And then I'm going to do the sine of the angle in between, right? So between 95 and 112, that's 76 degrees. So sine of 76. And plus, so the area of this triangle plus the area of this triangle is going to be the total area of the whole lawn. So that's the area of the first triangle. To find the area of the second triangle, I have to do, let's go over here. So I have 78 here, and I found that this was about 128 something. So let's go ahead and do that. So it's going to be 1/2 times 78. This number right here was 128 point, right? Remember, don't use the rounded number. So 144, da 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 da, sine, and we're going to find the sine of the angle in between, which we just found out was about 129. So it was actually 128.66, da da da. Okay. So now you take this whole thing, you plug it into the calculator, right? So 1/2 0.5 times, let's go back, 95 times 112. You could plug this in, right? 95 times 112, sine of 76. Let's close those parentheses. Plus, here's where we use some rounding things. So 1/2 is 0.5 times, this was 78. So that's straight a number, times 128. So that answer is, do I have that answer somewhere? Right here. There we go. So I'm going to take this answer and bring it down. You see what I'm doing? And then I'm going to do times the sine of, so sine of this 128.66, which is right here. All right, and I'm going to hit enter. And so this answer is about 9,064. So this is equal to 9,064 point, what is it? 169. And if I want to round this to about 3 significant figures, this is 9060. So 9060, what's our units? Should be, no units here. Units squared, right? Because this is area. All right. Whew, 19 minutes, 2 problems down. All right, so for the first part, it tells us that the distance from C to B, so from C to B, this distance right here, is 85. And they're asking us to find the A, which is the height, okay? So it's the height of that right there. So the whole thing is 85. So that means that for the height, it's going to be 85 divided by 2. And 85 divided by 2 is 42.5. So 42.5 is going to be our A, our small a. Okay. For our B, We do need to know our B is how long it takes to make a full rotation, and it tells us right here the wheel completes one rotation in 12 minutes. Okay, so that means that our period, right, how long it takes to make one cycle is 12 minutes. So if we want to find out this letter B right here, we have to use the formula period is equal to 2 pi over B. So we know that our period is equal to 12. So instead of P, I can substitute the number 12 here. So I cross multiply 12 times B is 12B is equal to 2 pi. To get the B by itself, I divide both sides by 12. And I get B is equal to 2 pi over 12, which is the same thing as pi over 6. So that's our B. So that's pi over 6 radians. All right. Da, da, da. Um, if I wanted to convert this into degrees, okay, because this is probably going to be easier in degrees, I would, instead of 2 pi, put 360. So 360 divided by 12. 360 divided by 12 is 30. So our B here is 30. B equals 30. So our A is 42.5 and our B is 30. Okay. All right. And finally, we're looking for the third part, which is C. All right. So to find out what C is, we know that this distance, they give it to us, from C to B is 85 meters, and from D to C is 5 meters, so this is 5 meters right here, okay? So we just found out in part A that this distance right here is 42.5, okay? So altogether, this distance right here from A to D is 42.5 plus the 5, so C is going to equal 47.5 meters, okay? All right. And the reason why is because at this minimum point right here, it's negative 42.5, and then this here is 5 meters down from that. So 47.5 is going to be that distance, and that is our C. Okay. Um, all right. So how many minutes is point C first at 50 meters in height? Is our part B. So we're going to plug in what we have, which h of t. So for part B, we're going to say h of t is equal to, so our A here is 42.5, but since it's down, it's going to be negative, so negative 42.5. And then it's a cosine, so that's COS. We found out that our B is 30, so I'm going to put 30, and then we're going to put T here, close that, plus, and our C is 47.5, 47.5, and we're going to set this equal to 50. So it says after how many minutes is point C first at 50 meters in height. So we're going to solve this, and again, we could do this by y1, y2. Whenever you're plugging this into your graphing calculator and on the test, you should do a sketch of what the graph looks like or what the graphs look like. And then you're going to say where they intersect. So our T, where they intersect, is about 3.11 is where it intersects. So 3.11, and after how many minutes? So that's 3.11 minutes. Okay. All right. So this shape is right here. It's made by adding a hemisphere to a cone. So hemisphere is right here. Here's a cone, and it's specifically a right cone. So that right here is 90 degrees. So we're asked to find the volume of the ice cream, okay? So volume of, I'm gonna go back to our formula booklet, okay? So a volume, where is our, okay, here. So volume of a sphere, okay? we have in front of us a hemisphere, so we have to take this and divide it by 2. The volume of a sphere is going to be 4 over 3. Let me come back to this. So volume of this part right here is going to be 4 over 3, and it's pi r cubed. Okay, that's the volume of the sphere, and then we have to take this and divide it by 2. Okay, that's going to give us the volume of the hemisphere. And then for the volume of this cone right here, that formula is going to be 1/3, right? And again, where am I getting this from? Volume of a cone, right, is right here. So 1/3 pi r squared h. Okay, so 1/3 pi r squared h. All right, so now all we're doing is just plugging some numbers in. So to find the volume, we're going to take both of these and add them together. So we're going to do 4/3 pi. Our radius of this cone, they tell us, is going to be, see, is a radius with a length of 3. So instead of our radius, we're going to type in or plug in the number 3, and we're going to raise this to the third power. Okay, right? Third power, and then we're going to take this whole thing divided by 2. Okay, then we're going to do plus sign, and then now I'm going to do the volume of the cone. So 1/3 pi, our radius is still 3, so I'm going to do 3 squared. And then the height of this, they tell us that the height is 5, so I'm going to plug in 5 here. So plug all of this into the calculator, and you're going to get that the volume is about 104, and our units doesn't have any units. No, but it's going to be units since volume is to the third power. So 104 units to the third power. Yeah, because it doesn't tell us in units. All right. So now for part B, it says find the total surface area. Okay. So if we're looking for surface area of a cone as well as a hemisphere. Okay. Okay, so I have the formula booklet up. So the surface area of a sphere is 4 pi r squared. So I'm going to come back over to the problem, 4 pi r squared. So 4 pi r squared, but again, this is going to be divided by 2 because we only have a hemisphere. And then we're going to add the volume of, I'm sorry, the surface area of the cone. So to do that, yeah, right here. So area of the cone is pi RL. So I'm going to come back. So I'm going to do plus pi RL. Okay. So now all we have to do is plug some stuff in. So we have, um, let's go ahead and find this L first, right? So our L is our slant height, which is this right here. We know that, let me change colors real quick. We do know that the height of this was 5, and we know that this distance from B to C, which is the radius, is 3. So I can do Pythagorean theorem here. So L, right, squared. Let me do this better. Remember, a squared plus b squared is equal to c squared. So I can use that because this is a right triangle. So I have 3 squared plus 5 squared is equal to L squared. So to find L, I do the square root of 3 squared plus 5 squared. Okay, so that's our L. So I can figure out what this is. So 9 plus 25 is 34. So L is equal to the square root of 34. So all I'm doing is just going to be like plugging numbers in. So I have 4 times pi times our radius, which is 3 squared. And I'm going to divide this whole thing by 2. And then I'm going to add to it pi times our radius, again, is 3. And we just found out that our L is square root of 34. So plug all of that into the calculator, and you're going to get that the total surface area is 112. And this is, since it's surface area, units squared. Okay, 112 units squared. Good. All right. The next question.